you guys. Happy Thursday. Today we're talking about atomic bonding. There's some short notes here for you. Just like yesterday, you should take your own notes on paper and send me a copy of those. And then you should also fill out the student response sheet as well. So we really want to talk about how and why atoms stick together. And that's going to be our focus for today. So why do atoms bond? There's a little article, hopefully you already read it, about the octet rule, and you should answer those questions before you complete these notes. That'll just help you understand a little bit better what's going on and why it's happening. So there's three types of chemical bonds. The simplest is the metallic bond, which is just a matrix of electrons holding a bunch of metal atoms together. We call this a sea of electrons. And this is really simple because all the electrons are just shared between all the different metal atoms. Some examples of this on the Earth include metal ores, so manganese, iron ore, lead, all of those naturally occurring metals have metallic bonds in them. The second type of bond is called an ionic bond. It's a bond between oh my gosh, excuse me guys. It's a bond between two oppositely charged ions. So an ion is just a charged atom. We talked about that yesterday in the last set of notes. And atoms become charged when they gain or lose electrons completely. They form cations, which are positive, and anions, which are negative. So once you have a positive thing and a negative thing, they can attract each other like little magnets, and that's how an ionic bond works. So we can use the octet rule to understand how ionic bonds form. On your student response sheet, you should answer the following questions. How many valence electrons does chlorine have? The Bohr model for chlorine is shown at the left. How many does it need to get to 8? And do you think it will donate or accept electrons? Why? Pause the video and answer these questions. Okay, so chlorine has 7 valence electrons. We're only counting the dots on the outside ring. Thus, it only needs 1 more valence electron to get to 8. So the easiest way for it to do this is to accept 1 electron. Otherwise, it would have to give away 7 electrons, and it's just not likely to do that. That's a lot harder than just accepting 1 electron. Now, do the same type of analysis considering sodium. How many valence electrons does sodium have? That should say sodium. How many does it need to get to 8? And do you think it will donate or accept electrons? Pause the video and answer these questions for sodium. Okay, so sodium only has 1 electron on its outermost ring, so it has 1 valence electron. If it wants to get to 8, it either needs to gain 7 electrons, which is a lot, or it needs to just give 1 away because the first inside ring already has 8 electrons. So in this case, it will definitely donate its electron. It's a lot easier for it to give away 1 electron than it is for it to get 7 more. This image shows how sodium can give away that electron and chlorine can accept it. Once this happens, sodium has 8 electrons in its outermost shell, and chlorine has 8 electrons in its outermost shell. And so both of these atoms are stable now. As a consequence, sodium has a 1+ charge because it lost a negative thing, and chlorine has a -1 charge because it gained a negative thing. After this happens, the positive sodium and the negative chlorine are attracted to each other like little tiny magnets, and this allows them to form an ionic bond. Valence electrons help us predict how something will bond. Because noble gases already have 8 valence electrons, they do not need to form bonds, and so they don't. They don't need to gain or lose electrons to be stable. They already have 8, and they're already stable. A little bit more information about ionic bonds. Atoms are gaining or losing things completely, and because of this, they have a positive and a negative charge, and they can be attracted to each other. In an ionic bond, the atoms involved are switching electrons and trading electrons between each other. So you'll always end up with one positive and one negative atom. So in this case, we look at sodium. Please, on your student response sheet, explain why sodium becomes positive when it forms an ionic bond with chlorine. Okay, so sodium donates its negative valence electron, and when it loses that negative thing, it gives it a 1 positive charge. And so that's why sodium becomes positive. Here are some common examples of ionic compounds in the earth. So halite is the mineral name for sodium chloride, which is really just salt. And so when we have 1 positive sodium and 1 negative chlorine, they come together. And when you get a bunch of them, they come together and they make kind of a little cubic structure, which you can see in the picture. And salt is a very important naturally occurring mineral. Limestone is another mineral that has a lot of effect on humans and what we do. And it's a calcium stuck to something called carbonate, which is made out of carbon and oxygen. So you have calcium actually gives up 2 electrons to the carbon and oxygen bond, and then that way the calcium and the carbonate can stick together. And this last one is made out of strontium and sulfate, which is sulfur and oxygen stuck together, and those also have a trade of 2 electrons, where strontium gives 2 electrons away and sulfate accepts them. And these big crystals can form out of strontium sulfate, and you can see the tiny orange people in this huge crystalline cave in Ohio. The last type of chemical bond is a covalent bond, where atoms share their valence electrons. Co means to share, and valent is referring to the valence electrons. So when this happens, the electron clouds end up being shared. This image of methane, CH4, kind of shows how this can work, where carbon already had 4 blue electrons, and then each hydrogen brought 1 red electron. So between all 5 elements, there are 8 electrons involved. Some examples that occur in the earth of these types of covalent bonds include quartz, sulfur, and elemental carbon. So quartz is made out of, silicon and oxygen. Sulfur is made out of sulfur. A bunch of sulfurs covalently bonded together. And then carbon, this particular example is graphite, and that carbon is all held together covalently as well. Bonding types, whether they are covalent or metallic or ionic, can be predicted using the periodic table. So if you have one metal shown in orange and one nonmetal shown in green, it's an ionic bond. If you have two nonmetals shown in green, then it's a covalent bond. If you have two metals shown in orange, it's a metallic bond. So this slide shows that little summary of what I just said out loud. All right, and so you will be asked to predict what kind of bonds different elements will form based on their location on the periodic table. There are two assignments that are designed to help us practice these. So this is the bonding POGL and the hydrosphere bonding review POGL. This is a lot that is assigned together. However, it will be due on Monday. There is not going to be a separate assignment tomorrow on Friday. This is going to be kind of a 2-day assignment. All right. Please let me know if you have any questions, and we will go over some of this content again on Monday. Thanks, guys.